Hello, welcome to Virtual and Security Learning. Thank you so much for your support on our previous video, which was on top 10 cybersecurity trends in 2023. And as we discussed and promised, we are going to make an individual video on each and every topic which was discussed in our past video. And our today's video will be on the 5G technology and its use. If you did not see our last podcast, I will post a link in a description box as well as it will be on the I button. I would request you please go ahead and have a look at this. So let's start with our discussion on the 5G technology. In this video, it will be an informative guide for you which will showcase the multiple use case of the 5G technology, why we need 5G technology and why it's very important to have a 5G technology. So let's discuss some small about the 5G technology. Before we starting with this one, let's assume that you have a road and you are driving a vehicle. So it will be very less traffic when the number of vehicles will be very less. But what happened? Suddenly in a city we have multiple houses. Every house has 3 to 4 cars. So what will be the output? Output will be the traffic will be increased, and due to that there will be congestions because everyone has a car. In the same way, in early 2018, what happened? Number of very few people was using a smartphone as compared to now. But after that, everyone is using a smartphone. So it will be a little bit difficult to serve those people requirement and the speed, and because due to congestion, and that's why we are moving towards a 5G. So the question comes, what 5G stand for? The 5G stand for the 5th generation, which is superior technology, or we can say the advanced version of the 4G. Okay, and it's referred to the latest wireless technology standard. There are some key features of the 5G which going to be offered by 5G. So the first feature which is everyone needed, that is ultra speed. Now, what do you mean by the ultra fast speed is? No, the 5G offer a significantly very higher data transfer rate as compared to the previous generation. It means, for example, when you was going to download a movie, in 3G it was taking, let's suppose, 26 hours. In 4G it was taking 10 minutes, but in 5G it will just take a few seconds because the data transfer will be on very ultra fast rate. So second point will be the low latency, which enable between the nearby devices. So now the question comes, how 5G will reduce a low latency? So basically latency refers to a time delay, and 5G is going to provide, 5G is going to be deliver 5 to 10 times lower latency as compared to 4G. But the question comes, how this low latency will be introduced in 5G, because as we know that 5G is going to be use a very high radio frequency to transfer exponentially more data over the air interface for a faster speed. And the third point, which is going to be a massive device connectivity. So 5G is going to be support large number of the devices simultaneously as compared to 4G, because the number of the devices support in 4G per square kilometer was 4,000, which is going to be 1 million in case of 5G per square kilometer, and it will also going to be enhance a reliability and provide a more reliable and stable network connection. It's going to be penetrate a multiple geographical object very easily. And we know that 5G is going to be support a single cell, small cell and micro cell concept. Therefore, it is very easy for 5G to be served and provide very good performance in a crowded area. And it will also address the increased demand of connecting the IoT devices. Okay. Now 5G also offer a greater stability and more coverage because of its capability to penetrate through walls and building to ensure the constant connection. Now let's talk about the evolution of the 5G technology, which is derived from his successor like 1G, 2G, 3G and 4G. So the first generation mobile communication system is known as the 1G, which is basically designed for the voice purpose, like it's called providing the, before that we was using earlier PSTN and the normal phone, and then we come towards the 1G. This is basically analog voice, which is used to provide voice quality between the two users. But there are some several disadvantages of this feature. So first of thing is they was having a very poor battery life. You can see in earlier we was having a big cordless phone, which was like very heavy in size and too much battery. But again, the battery life was very poor, as well as we talk about the voice quality, and the voice quality was also very poor because of lots of the interference between the frequency, and the size of the mobile was very big. It was not easy for anyone to carry out. Okay, and they were of course very less secure because they was using this FMD modulator. And also the one more big disadvantage in the 1G technology was for the limiting the number of the user per cell, and as well as there was no roaming introduced inside a 1G. And then what happened after that? I think the 1G was firstly deployed by a Nippon, and then later on from the 1G we moved towards 2G. That was the second generation mobile communication. We can use it. Now the 2G was offering some couple of features. They were also offering a digital system like a PS4 or CS switching system. That may be discussed sometime in future videos if it is required, because it's more on the code concept. Other thing which was offering 2G is like the SML, as well as they also introduced a roaming inside a 2G. So when the roaming got introduced, it was easy for people to be roam. If they are roaming anywhere, they can carry a devices, as well as it's introduced a enhanced security feature as compared to 1G. Still 2G was not properly secure, but it's far better than the 1G. Okay, they also use encrypted voice transmission, and they also provide a first internet which very lower data rate. Like the internet speed in a 2G were like 64 kbps in web, which was web. Then they was not having a proper mobilities, and again the major problem is the serving the user or serving the devices in limited area. Later on we move towards 2.5G called EDGE, and then the third generation of this technology got designed, that was called 3G, which was based on the 3GPP. And little bit one more advantage of the 3G was to provide some enhanced feature which was not covered inside of 2G. So inside the 3G, of course the data rate will be higher as compared to 2G, as well as this also support the first video calling as compared to 2G. So first for video, but again the problem was with video calling is the quality, because the 3G was not again a stable connection. Serving the multiple devices is not easy, and as well as there was a huge congestion. So but yes, video calling was possible. They also enhance securities and increment more number for users, as well as they increase the coverage. They was also having a mobile app support inside this one. They were also having location tracking. You can also using video streaming, TV streaming, or media streaming, as well as there was some high quality 3D games got introduced. Then apart from 3G, then there is a one little bit advanced version of 3G called 3.5G, which we already know as HSPDA, which was using inside a dongle, or HSPA plus. But unfortunately there was some disadvantage for 3G, like the licenses were very expensive for spectrum, and the cost of the infrastructure and equipment and their implementation was very high, as well as the bandwidth requirement. And the mobile devices, in early when we started using a 3G phone, you can see the mobile devices, they are going to be very costly. So to overcome some drawbacks of the 3G, there was a fourth generation got introduced. This is like the fourth generation communication system known as the 4G, or many of us is already known as the LTE. So LTE offer such an advanced feature. The first thing is they are providing a much more higher data rate, which can go up to 1 Gbps, and of course the security and mobility is got too much enhanced as compared to 2G or 3G. And of course we can see there is live people who was doing a live video streaming or high quality game they was playing online. And of course for voice purpose, the good feature which is got introduced called voice over LTE. But again there was some disadvantages. Of course each and every technology has advantage and disadvantage. So few disadvantages was the spectrum cost was very expensive in most of the countries, as well as the hardware infrastructure was again costly, but it's still better than a 4G, of course. And it is very difficult to be because it required a wide level of deployment and upgrade, which is time consuming. And now again there was one more limitation with the 4G to serve multiple devices in a limited area. So 4G has capability of, as compared to 3G, yes, 4G capability got increased, but 4G was still able to serve 4,000 devices per square kilometer. And then we come towards a fifth generation, which is known as the 5G, okay, where all the devices will be able to communicate to the internet. Now When the 5G network got introduced, they have multiple features which we have introduced, like the internet speed, which is going to be much more faster than 4G, as well as the very low latency, which is going to be 5 to 10 times lower than 4G. Of course, since it's a zero trust architecture and secure by design, they are going to be offer a very high security, okay, and the total cost will be deduction for data only, not for a voice, which is a major advantage. Like the VoLTE, the total cost will be deducted for a voice data, and same concept they are going to be used over voice over NR. And of course, this is a cloud-based infrastructure which is going to be used, and it will also going to provide real-time communication and streaming, like you can use your XR, extended reality, virtual reality features, and many more. So the question come basically, when we was having a 4G, what was the reason that we moved towards a 5G? See, 5G was of course much providing, as we already discussed, is providing much more advanced feature, but there was some drawback which was having in a 4G. First of all, the complex hardware. The hardware was very complex and connectivity was very limited, as we discussed earlier, as well as there was some internal communication issues was there. If we talk more about the advantage of the 5G or 5G, the 5G is providing a flexible frame structure and a wide bandwidth. And the major advantage of the 5G is basically a beamforming, as well as of course the one thing which is introduced inside of 5G which is playing a very good role, that is called slicing. Because now when we say we are going to be serve multiple devices and multiple technology in a very small time or limited coverage, it means that we are going to use a slicing functions. The security is also introduced inside of 5G, and the slicing, which we are going to discuss in earlier slide, an upcoming slide, where like how slicing play a very good role in this one. But there are some couple of the features which are still a limitation, for technical limitations from 4G, which is like for especially for connected cars, smart offices, smart cities, and autonomous vehicle. Still, because the serving device capability and due to the latency in a 4G, we have to move towards a 5G. So let's take example, one of the very example, as we discussed earlier. Whenever you have to download a very big movie. When we was using a 3G, we was it was taking 26 hours to download this one. But when it's 4G comes, it reduce the drastic change on the time consumptions, and it come to this 6 minutes. And now 5G again introduced very good speed, and they reduce the timing from the 6 to the 30.6 seconds. This is like general analysis which is happened. So before 5G technology, what we was having, as we already discussed few of the features, like the devices supported and the internet speed and all. But how 5G will play a role, which we are going to be discuss. As we know that in 5G we are increasing a particular people. So first thing, we are going to reducing the latency, as well as we are providing a higher data rate due to higher radio frequency, as well as using the beamforming. And we are also supporting some of the devices which has very low power, but also providing a good connectivity to them. So if you can see this three verticals where the 5G is going to be play a very crucial role. The first thing is for the IoT, as we say that the 5G device or the 5G connectivity will consume a very low energy, and then since this is consuming a very low energy, it is very good for such a device which has a big battery life, because they are a battery operated device. Most of the IoT are battery operated device, so it is very good for them. They are increasing their shelf life and consuming a less energy, as well as the coverage is very much more coverage we are providing because of this beamforming and the penetration skill of the radio wavelength towards buildings or natural objects, as well as one of the major things which we are going to provide the complexity where you are providing in the 5G. So 5G is providing a very ultra low complexity, which is just like a 10 second per bit, which is very good. And the mission critical systems, like 5G is already secure by design, so it's very good for the financial trusted, for health organizations, for government, for smart cities and all, as well as of course the latency. And when we discuss about the slicing, because what happened in 4G, when you was using, the latency was more, but now with the slicing function in the 5G, as I'm again talking about the slicing, which we need to be discussed, this is very detailed word there. Because what happened, this latency requirement for each type of the business or each type of the industry is always different as compared to the constant requirement. For example, maybe the reconnected maybe the real-time hospital system. They required the latency does not make an impact for them, but speed make a very good impact on this one. For example, the IoT devices, okay, the latency should be very low, but no, they need a very small or they need to be accessed different functions. So that's why it is like each slice will offer a different role there. Now, so we say that how 5G deployment will work here. See, so as we all know that each and every telecom network will have a two part. The first one will be the radio access network, another will be your core network. The radio access network basically a part of the interface, and core network will be the telecom providers like the Airtel and all. They have the backend infrastructure, Jio or Telenor, whoever we are talking about. So in the radio spectrum, basically they have five things. The first one will be the towers, like all G node Bs or E node Bs, which we see in our BTS in 2G we were seeing there. Apart from tower, they have small cells, and again these small cells are also divided into micro cells. So they are using MIMO function, like they have multiple input-output features, which is designed for MIMO, massive input, massive output, and the beamform technology, which can help us to provide a wide coverage and serve multiple devices. Inside a core network, basically, they have their data network and their core component to serve the 5G. So now in a 5G core network, basically the three functions or the three security features is going to play a very crucial role. First is the network function. Network function is the one which will serve your requirement or which will serve a user requirement, right? Like some of the functions we can talk about like AMF, SMF, PCF, AUSF and all. In this video, we are not going to discuss everything in detail because it is going to be very big chapter now. But second thing is the virtualization. As you know that in 4G, the hardware are playing a very crucial role, and it is very it was not cost effective because the cost of maintenance of the hardware is much more higher. So we are moving everything towards virtualization and network slicing, which is going to play a very crucial role when we providing 5G as a service. So let's talk about our next sections like the 5G network stack. So when we compare our 5G network stack with the OSI layer, like physical layer, data link layer, network layer, transport, session, correlation, and applications. Similar way in a 5G we have something called OWA layer. Apart from OWA, you have a UNL and LNL. Then we have a OTP layer, and last one is application and applications of services. The first layer or the OWA layer, which is known as the Open Wireless Architecture. This is similar, and or we can say that its functionality is fully similar as a physical layer and data link layer in OSI stack. We are not going to discuss complete OSI stack here, as the video is going to be very long. Next we go towards network layer. Basically, the network layer will be divided into a two part, upper network layer and a lower network layer. So let's talk about the functionality of this network layer. Basically, it is used to route data from the source side to the destination devices or destination system, and it's divided, as we already discussed, divided into a two part. Apart from that, when we say the routing of the data, means for example, if you are requesting for a voice, or if you are requesting for data connections, if you are requesting for video calling, or let's suppose you want to send some MQTT based data. So this is the routing will be played in routing role will be played by the this network layer. The third layer, basically, which is known as the open transport layer, is basically combining the functionalities of transport layer as well as the session layer. Again, it is the same function what is used by transport and session layer in OSI model. So we are just going to skip it because we have multiple topics to be covered in this podcast. Let's talk about after this one, the last layer what we have is called application layer. Basically, the role of the application layer is basically mark the data as per the format required. It also do a basic encryption and a decryption part of the data, and it's also select the best wireless connection for given services. Okay, and so this is a architecture of the 5G network architecture. Let's move towards the 5G deployment. So here basically when we talking about the 5G deployment, so basically 5G deployment has two options. One is the NSA, another one is the SA. Inside the NSA, we basically have either option 3, 3A and 3X, or we can call 4 and 4A. Inside SA, basically we have option 2 as well as the option 5. This is basically the way how this 5G is deployed into the SA, which is known as a standalone, and NSA basically a non-standalone. So a basic concept or basic difference between standard and non-standalone is like when we are talking about the standalone, it means we are going to use a full 5G core. Like each and every features will be from the 5G core. We will use 5G radio and core part. When we talk about the NSA, here we are going to use some of the functionality from the 4G. For example, either we use the 4G core, either we are going to be use a 4G radio system. So this is a non-standalone. So first option is known as the option 1. Option 1 basically implementation of the basic traditional LTE with the EPC. So as we already know that in our 4G we was using LTE eNode Bs, and then we was in the core side we have EPC packet core. So this is option 1. Now when we go towards the option 2 basically is like we will use a NR feature, or we are going to be use a NR for communication with the 5G core without using a LTE anchor. So when we talk about this option 2, basically we are talking about the SA, where we will use a G-Node B, which is an extended or enhanced version of the eNode B inside of 5G, as well as we are going to use the full-fledged 5G core in option 2. When we talk about the standalone option for a 5G, in the same way what we can also use a eNode B or a 4G tower as a radio part, and then we are going to use 5G core. This is option 5 which we are going to be used. Now if we talk about the option 3 and 3A, so often option 3 or 3A or 3X, basically whatever, it's work on a master slave node concept. We might use 5G eNode B as well as the 5G G-Node B, but the backend core will be the EPC. So eNode B means like whenever there is a 4G tower, it will be play a master node, and G-Node will be the slave nodes. So first of all, user will authenticate it on a 4G, then it will move towards the 5G if the phone is supported by 5G. But every communication in a backend will be handled by EPC. If we talk about the 5G 4 or 4A, is basically again a master slave concept, but in this case what happened, the master node will be the 5G node. So when user will have 5G phone, it will authenticate it over a 5G G-Node B, as well as then it will do more to and all the authentications and authorization will be taken care by 5G core node. And then we can also use eNode B or 4G tower as a slave node in case of the 4G service required. Now in case of 7th or 7th, what basically we are going to be used, we will use eNode B as a master node. But in this case, now rather than using a EPC as a backend communication, we will use a 5GC or a 5G core for a backend authentication and authorization, and the 5G G-Node B will be used as a slave node. So this is a little bit confusing architecture, but yeah, if you want, we can make a in detail video on the detailed implementation of the 5G architecture. Now, as we all know that, correct, when the traditional industry is going to be digitalized, or they are going to be mobilized, like before that you can see there was a physical things was there. Now everything is transformed into a internet base, because what happened is we have all the games, or now since the XR has come, we don't need to travel too much, or we are playing games now. You can see nowadays very less physical activities, or more everyone is like connected. So all the equipment which was used by traditional industries, like if you see the earlier industries like the mills and all, they was manually operated. Now they are moving towards a digitalized. So everything is connected. So since the industry is getting transformed from the one phase to his advanced phase, what happened? We required a more connectivity, because we required a more intervention from the operator side. Because earlier what happened, you can see there was a manual controller or a guard who was doing a manual work, or manual pullover, or a shift where they use and they operate the functions and all. Nowadays for everything we have an application. Let's take an example. We was going for a shopping in a market, we was going to the shop, we were checking the clothes, we was buying the stuff, grocery, and taking it. Since the industry is getting digitalized, what we are doing, we have a multiple online and e-commerce platform. We just open, we just see whatever we have to use it, we just click and we buy. And for every small things we have applications, correct? So what happened when we have multiple applications? What we have to provide a limitless connectivity, a faster speed to serve the purpose of the application. For example, you are doing let's talk example. In earlier, if we talk about trading, like before, people used to go into the stock market and they used to trade with a broker. Now we have multiple online platform with the application to serve our feature. So let's take example. Let's For example, we have mobile industries, or we have a medical industries, automobile industries, trading, crypto, streaming, shopping, e-commerce, multiple industries. Now in 4G, what happened? There was only one type of the network but designed to serve this multiple industries. But what happened? This is not an actual good practice. Now for what happened? For serving this multiple industry, we have a one network, but inside the core, you can use a different functions for serving a particular feature. It might possible that for example, if you want to do a voice call, you don't require multiple things at a time, or you might suppose if you are using medical industries, correct? For there, the real-time communication is playing more crucial role as compared to the gaming, because if the delay in a gaming can be acceptable as compared to the delay inside a medical industry. So now to analyze those features and analyzing those requirements based on the applicability. For example, let's take one more example. We talk about let's say there is a 5G IoT. Now inside IoT, our requirement is we require a very low power, okay, but the density should be high and the reliability should. If we talk about the V2X, or example the connected vehicle or autonomous, what happened? We require it's not about the very, we require ultra low latency. For IoT, low latency will be okay, but we require a ultra low latency. Bandwidth should be moderate and the reliability should be ultra high as compared to IoT. Or if we talk about the connected user, we require the ultra high bandwidth, but latency can be acceptable. We don't need a very ultra high latency in case of the UHD video calling, and the bandwidth should be moderate is also okay. So for serving such a purpose, because as we know that the quality of the service, separation of the network, what we have done, we have designed a slicing. So what the slicing will do? Slicing is basically a network function which will be respond based on the user requirement or the user devices. And now we will have a slicing function inside the slicing function. So what we will do? We will create a multiple slice. For example, you have one brick of ice cream, you are eating alone. What you will do? You can create a multiple slices based on everyone's requirement. For example, I want a bigger slice, I want small size. The same way, we're creating a small slices for this network function to serve a purpose. So one slice may be for mobile broadband, one slice may be for the fixed wireless, for public safety. Now when it's come to the public safety, of course, this is play a very crucial role. So we should need to give always priority to the public safety. Okay, for a mass event, for industrial automation, we are creating a multiple slices. So inside these slices, what will happen? We will design those network function based on the requirement that which network want to access which feature, okay, for each VMNO or each industry, and this is called a slicing. Here also we are not taking everything in a depth, because it's also required to have an individual session for each and every component in a 5G. So now let's come to the example how 5G benefits a business. This is one more industrial applications, because as we know that since a 5G provide a very better speed and latency, multiple things is going to be solved there. It will also provide also help us to increase the productivity. Business can move a large amount of the data without worrying about the network issue, because full industry is digitalized. It also support business growth, because business won't have to worry about adding more connected devices that may essentially that move essentially data to the network. And future work, superior connectivity can be further open up a very high business demand coverage and provide a more advantage. Now, how 5G will help us into the individual life? Okay, because it can also provide user can have a better experience with tech system, including the cloud services, augmented reality, virtual reality, online gaming, and all. They can also have as we know that 5G equipment is energy efficient, so using 5G tech can significantly reduce energy consumption, which can play a very important role into our environment. And also the remote healthcare, this is one of the use case we are talking about. The healthcare can be also access the patients, or let's suppose before that the one doctor need to be travel from one location to another location. But now what we can do, they can provide a real-time performance monitoring and remote. They can also perform a remote surgery in a real time without traveling or without moving from one location to another location. Now, these are the major 5G use cases. Basically, the used for the broadband and the media everywhere. They're supposed to be used in the smart vehicle and transportation, mission criticals, human-machine interaction, and the sensor network. If we talk about the business use case in the real time, okay, so how 5G is play? 5G is going to play one role inside the precious agriculture. Now, how it will going to be driven? You will have your dedicated private network. In this private network, what happen? You will have 5G connected device which will go and monitor your agriculture land, which is going to monitor your agriculture stuff in a real time, also giving you for example, if you seeing this cotton, yes, it will give you the real time information that okay, this is going to be, this fossil is going to be grow or is going to be damaged in few time, what this particular things required. And also this is one more thing. Another one is the real time shipping, because we know that shipping industry is very large and transportation is very large. So with having a private 5G network, you can establish your own personal network there, and then you can track each and every asset in a long time. Same, this will also help us to detect any real time accident or event in a smart logistics. So it will immediately, if any incidents happen, it will immediately update and you will see everything on your billboard. Now the autonomous driving, of course, we will have a connected cars, and the driverless cars is a new technology which is going to become. So 5G will also going to play a very crucial role on this one. So thank you so much. I think these are the use cases we have discussed, and I think we have covered up a lot on a 5G technology. I really thanks everyone for giving your time, and wish you all the best. Please feel free to reach us if anything is required, if you need any other information on this one. And also we request you to please do like, share our channel, and please let us know in comment if you required any other video on or any other trends.